does it take to win this race? Well, you must be willing to live your life with a constant companion: pain. Pain is a big fat creature riding on your back. The harder you push, the tighter it squeezes your chest. The steeper the climb, the deeper it digs its jagged claws into your muscles. If there is any doubt that Lance Armstrong has spent his fair share of time wrestling this beast, you need only look at the facts. While at the top of his game, he was nearly felled by the great equalizer, cancer. What's amazing is not that he beat the disease. That, to a certain extent, is a matter of fate. What's truly inspiring is that he came back, and that he came back even better than before, stronger, smarter, faster, and more determined than ever to be a 7-time champion. Color and a few $1 million worth of scientific equipment. On this day, Team Lance was able to make a great technical discovery. A series of minute changes in Lance's position on the bike would save 1 minute 36 seconds over the course of the time trial at the Tour de France. In fact, virtually everything is tested in the wind tunnel, from body position to the shirt on Lance's back.
When we look at parallel equipment, one of the interesting things in studying in the wind tunnel, we found that 2/3 of the drag comes off the body, whereas only 1/3 comes off of the bike itself. We recognize a huge opportunity to help the athlete's body be as efficient as possible.
Similar to the way a golf ball is designed, there's actually a texture on the golf ball, the dimples, and what the dimples do is they actually help the ball go farther and faster. The dimples create a sort of artificial turbulent boundary layer, increasing the surface friction of the ball itself. But the trade-off is that that flow, as it wraps around the ball, sticks to the ball a little bit better, so that by the time it peels off the back of the ball, there's a much lower pressure drag coming off the back. We found that we could essentially apply the same principle to different parts of a cyclist's body.
If Lance's sleeve were smooth, it would form a low-pressure zone directly behind his arm, creating drag. Applying a dimpled texture to the surface, just like on a golf ball, shrinks the trailing low-pressure zone. This reduces aerodynamic drag and allows him to go faster.
We found that certain objects of certain sizes, they need to be in a textured finish. You know, cylinders that are about the size of biceps, about the size of a lower quadricep. So we definitely don't want to put just simply a smooth surface over the entire body, and we don't want to...
Sure, in 1999, we basically won it with, I don't want to say inferior equipment, but we did not pay attention to much detail. We didn't have a lot of that stuff at our fingertips, and every year after that, we started to change things and became known as these guys that were just possessed and obsessed with technology.
We don't deliver custom frames to the Discovery team. They write off-the-shelf frames, so we're constantly looking for new things to improve ride quality and ride feel.
The most significant revolution came with the use of carbon fiber in frames and wheels, which was borrowed from the aerospace industry.
This is carbon fiber. It's multiple plies of carbon fiber laid down in a sheet that then we cut with a special knife system that's on the CNC cutting table.
Carbon fiber is made by charring synthetic fibers to increase their strength.
We would never want to make all of the pieces parts all the same thickness. The bike would be way too heavy. So what we are doing is we are structurally reinforcing only those areas that need it, and so therefore lightening the bike up and yet maintaining performance. This is a 2005 Madone frame, and it weighs about the same as a paperback book.
Since we have all the latest tools and technology, there's no making a mistake when we're developing product for Lance. Lance is very well known for being able to pick up millimeters of change.
How's that feel?
Too short. 2 centimeters too short.
Then we have tools to be able to make sure that we get everything in the right place. Using software and hardware, we created virtual prototypes that we're able to analyze and to virtually weigh, virtually optimize, and virtually visualize way before we made anything. So the only thing we can't do right now is virtually get on the bike and ride it, which we're working on.
One of the things that we were able to do with the Madone that we hadn't in the past was use some new technology. And that technology was computational fluid dynamics, or CFD. With a partnership with AMD to get us faster computers, we were able then to run the Madone parts in a virtual wind tunnel. We were able to see a couple of things. One is the actual airflow around an object. We can actually check the aerodynamics of a bike without having to spend time in a wind tunnel. It also shows in the colors high pressure and low pressure areas. We can try changing the shape, changing the position. And then when we finally come up with a final design, we can go to the wind tunnel and verify those results.
One of the two things that Lance is always demanding, one thing is lightness or lightweight, and the other thing is stiffness.
Lightness, because it's less weight to haul up the mountains. And stiffness, because it allows more pedal power to be transferred to the road.
We have a benchmark for what Lance likes, and then we can create a frame that is either more or less stiff depending on what Lance is looking for.